Welcome. In this video I'm going to show you how you can obtain Cohen's D using Python 3, specifically in JupyterLab. And this is going to be Cohen's D for the one sample t-test. There are a few other versions out there, so be careful. This is just for the one sample t-test. It's an effect size measure that we can use in that situation, and it's being defined as the average minus the sample average minus the hypothesized average divided by the standard deviation. There are some other ones, so for example DS, that's used for an independent samples t-test. You also have one for a paired samples t-test. I think there are a few different variations. This one is actually labeled in Cohen's book as D'3, and he does also mention that it can be converted to a generic D by multiplying it by the square root of 2, and that's somewhat important for the interpretation because he gives some rule of thumb for the interpretation. And again, these are rules of thumb, so they can vary per field, but they might sometimes be helpful. So 0.2 is anything below that is neglectable. Between 0.2 but under 0.5 small, medium, large, you see the criteria. So let's find out how to do this with Python. Well, I need some example data for that, so I'll be using pandas to load some data in. So I'm first going to import pandas. If you've never used pandas before, you probably first have to install it. So I think it's pip install pandas in, but have a quick Google search, shouldn't be too hard. Read CSV can then actually read the file, so that's what I'm doing here. And just to show the first few records in there, it's giving me a warning about some columns, but it's just an example. I do need a numeric field, so I'm going to be using age, and these look like numbers, but actually there are a few missing values, so I'm going to drop those. There's one category actually in there, so 89 or older, so I'm going to simply replace that with 89. That might not be the best thing to do, but it's just for an example. Change all the values to numeric because there might be some apostrophes floating around some numbers, and then I should have one nice my field 3 which only has numbers in them. In it, there's only one. I'll set my hypothesized mean at 50. That's a choice of the researcher. So this is a follow-up on a one sample t-test. So check my video on one sample t-test. Hypothesized mean is the one that you would expect in the population. I can then use mean because I also do need to subtract the sample mean from. I need to subtract the hypothesized mean from the sample mean. I'll use the mean function from pandas because I already loaded it. I have a separate video on mean as well if you want to use NumPy or don't want to use pandas at all. Determine the difference then between the sample mean and the hypothesized mean, so that's going to be that bit. And the standard deviation, I'll use the standard deviation from pandas. There are other ways to do that. I have a separate video on that as well. But since I loaded pandas, it's so much easier to simply just use that. Then Cohen's D, or at least the one for the one sample t-test, that's why I said OS in here, is simply that D divided by the standard deviation, and in this case is minus 0.10. To see which category that falls into, I'll multiply it by the square root of 2, which can be done by raising something to the power of a half. And that gives me then the regular D, and that would actually be neglectable, but I can also use Python to do that with an if and then some else ifs, and that then shows me neglectable. You could make one small function out of this if you're interested, and thank you for watching. I hope this was helpful.